Can you see my screen?
Yes, now it's visible. This side is visible.
Oh, mine.
Yes, yes, you can see it.
Because I was getting worried because I wanted to share my codes with to you. So if my screen was not shared, I was going to face some challenges on the examples. Okay, without wasting time, let me delve into my presentation. I'm going to present on encapsulation. On behalf of all the group members in group 4, I'm sure that we are about 15 members. I'm sure as the presentation is will be commencing, the other group members will be joining. So I'm going to talk about encapsulation now. Oh, sorry. Okay. Tanya has shared this now. Okay, let's use this one. Tanya, can you scroll down your slide? Okay. Let's see. Look at an overview of what we have researched on our side as group 4 members. Let's start about the introduction side. So in this presentation, we are going to focus on the access modifiers. We find terms in on inheritance, and I use object-oriented programming. And also, we are going to give you some examples on the encapsulation, inheritance, and polymorphism. Can you scroll down, Tanya? So first of all, I want to talk about first. Before I start the presentation on encapsulation, I want to talk about access modifiers, because these are we are going to talk about another one of the modifiers, which is a private modifier, which we are going to talk about in encapsulation. So before doing that, I want to sail you through the access modifiers. So access modifiers control the access level. For class, you can use either public or default. Public, the class is accessible by any other class. Default, this is the class is only accessible but in the same package. This is used when you don't specify a modifier. For attributes, methods, constructors, you can use the one of the following. Public, the code is accessible for all classes. Private, the code is only accessible within the declared class. Default, the code is only accessible in the same package. This is used when you don't specify a modifier. You will learn more about these packages in some in the packages chapter, and you will also have protected. So these modifiers, they help us to hide some other stuff from other classes in our code. Let's take for an example. When you are encapsulating, we declare a private modifier. So I want to talk about that one, but before I do that, I want to explain to you what is encapsulation. Encapsulation is like a capsule. Does anyone know what a capsule is? Does anyone know what a capsule is? Anyone
Yes, we know it. It's a
from
tool.
group
Something
4
like given at the hospital.
can explain to us what a capsule is, so that presentation will not. I can hear you.
I think a capsule is something that
Come again.
it's a tool we are given in the hospital when we are sick.
It's still like a pill, right?
Yeah, pill we are
Have
given
some medicine inside it.
Yeah, it's normal when we have STD.
Okay, okay. Okay.
So
Okay,
it
it's
gets some medicine.
like an example. Okay, okay. So someone was explaining about the capsule. So encapsulation is like a capsule. The work code and data is bounded together in a single unit. So when we're encapsulating our data or our code, we want some of the information that we don't want the world or the other classes or the public to see. So we try by all means to bound those codes into a private modifier, so that they cannot be accessed to other parts of the source code. And also is a protective shield that protects the code from being accessed by the outside. This shield outside this shield. And also variables and methods are defined in class capsule. So when you are encapsulating, you define variables and methods in a single shield, so that they cannot be accessed with other members on the outside of the code. Sorry, my vocabulary on Java is a little bit lousy, so forgive me on that. And also, to protect the data, variables must be private, and they can only be accessed through methods. Creating, so before I continue, I will scroll down my PowerPoint so that I can give you some of the pointers on what we are going to talk about. And after that, I am going to give you 2 examples, so that you have a clear overview of what encapsulation is before we proceed to inheritance and polymorphism. To achieve this, you must declare class variables or attributes as private, and also provide public get and set methods to access and update the value of a private variable. So in another example that I'm going to give you, you will see that I'm going also to update, show you how to update the data for a private variable. And also I'm going to show you how to get and to use getters and setters methods to access the data. So get and set, as we learn on access modifiers, you can see that private variables can only be accessed within the same class. In outside class, there's no access to it. Like for an example, income, you cannot the employees remuneration, but only the HR can also can only have access to that. But not all the HR spheres, the employee benefit got HRs who work on timesheets, so everyone can access the data. And also you can, however, it is possible to access them if you provide public get and set methods. The get methods return the variable value, and the set methods sets the value. Syntax for both is that they start with either get or set followed by the name of the variable with the first letter in uppercase. You can scroll down, Tanya. Here is a short example of what I'm talking about. You can see here there's a public class person, and on this public class person we've got a private string name. This private the name of the person is not going with the other classes, with other on the code, but it is hidden so that it cannot be accessed on the outside of the code. And also we have a getter method here, a public string get name, then it's going to return name, and also it's going to set, this is going to get, we are going to get the name, and this is going to set the name. So Tanya, can you explain this part, public void set name, or the word void, what is it going to do to this code when we get the public void? Can you slide back? Can you explain this part? Public void set name. Public void set name. Can you explain the part void? What is it going to do to this code?
Okay, the void is the return type. It means that set name method is not going to actually return anything. So it's void, meaning that it's going to return nothing.
Okay, okay. I think your mic is a little bit, your volume is a little bit low. Can you try to improve your volume so that some of the guys can hear you well?
Okay, guys, can you hear me now?
Yes, Tanya.
Okay,
we
yeah.
can hear you, sir.
What I'm saying is the void here is
Yes, we can
it's
hear
actually telling us that the set name is not going to retain anything. So it's not going to retain anything. That's why it's been set to void. So we don't expect anything to be returned from the set name method.
What do you mean by returning?
Returning is the value that actually comes after we call the method.
Yeah.
Are you satisfied?
Okay. Are you satisfied, guys? Are you satisfied? I think Tanya has tried to expagorate on this part. Okay.
Also, guys, I think on your level, I think you are now well versed with the programming. Zvekuti zvonizo hatingachatarisiri kuona vanhu vachibvunza kuti what's returning there. I don't think is tikufamba tese.
Yeah, that's cool.
Because from your C programming level, you were taught function calling, may function return type,
that's
how to declare a function, and you went on to do C++. That's when you were introduced maybe to these technicalities of methods, and it's just the same as a function. It's only that in OOP you call them methods, and then you went on to do maybe visual programming, not visual program, visual programming, and you are using the C#, and you are still, and I'm still wondering why are you not able to understand the function return type, and the function return, or the return type, if it is void, if it is a string, or if it is going to be returning an integer, something like that. I think it's something that we must be well versed with by now. So please, let's make sure that we put our house in order, please. Thank you. You can proceed.
Okay, say thank you for clarifying on this one, on that one, and also, okay, say thank you for giving these guys a little bit heads up on what they are supposed to be to remind by now. As we proceed, can you try to scroll on your slide? Yeah, Tanya. Okay. This part, okay. The get method returns the value of the variable name. This one we've talked about this on the previous slide. Okay, can you try to scroll down again? Hello, Tanya.
Yeah, I've scrolled down. It's only that the network, I think,
I think
slow on my
okay.
side.
If the variable we would expect it following output John. However, we try to access a private variable, we get an error. It's a little bit down there. Let me try to share my screen so that I can give you an example. As we try to code. If you are able to see my screen, yeah. Can you tell me, guys, so that you can proceed?
There's nothing. Maybe you can try to rejoin.
Can you see my screen?
Maybe it can work. Maybe it can work. Or someone in your group can. Or someone in your group can do the example.
Try what is the example. The example. Tanya, do you have any example there?
They must have it.
Maybe we can actually make one because I currently don't have one at the moment.
Let me try to make you a presenter. Maybe you'll be able to share your screen.
Yes, for me, I've
try to make to share your screen now. Try to share your screen.
All right. Can you see my screen now?
Not yet. Are you sharing a window or you are sharing the whole screen? Try to share the whole screen.
Not yet.
Yeah, not yet. Try to share the whole screen.
Okay, let me try to share the whole screen.
Yeah, it's not working. Are you sharing?
What about now? Can you see my screen now?
Not yet.
Yes, I'm sharing, sir.
So I think there is a network delay. So maybe.
Not yet. I think that
So someone in your group can share the screen and do the example, then do an example. They demonstrate how to achieve encapsulation. In your group.
Okay.
Yes. That's why you are not alone in your group. Okay, not trying, but you have to do the example.
All right.
Yes.
Okay, can you see my screen now?
Yes, we are seeing it.
Okay, so now I've just opened my Eclipse. So I already have a project in the package. Yes, I'm going to create classes where I can implement the encapsulation that was being presented by Shannon. New class. So
I
I'm
can
going
see
to
your
go-
screen, Tanya.
Can you see it? Okay.
No, I
we're going-
can't.
oh,
Now I can see it. Now I can see
On my
it.
side, I'm seeing it.
okay, so I think it's Shannon's
Okay, now.
network then. Okay, so I'm going to create a new class. Let me just name it person letter P, right? Then I'm going to create a main class where we are going to implement this code. So we're going to actually put our fields in this class. We're gonna make them private. Private. Okay, so now we're going to create the getters, the setters to implement encapsulation. We have to make them public so that we can access them from the main class. Public void. Can I see the?
Yes, I'm still there.
Yeah, you can help me here as we go.
Okay.
Hello, what's happening here?
Yeah, I'm trying to get it right there.
Ah. Yes, woman.
Okay. Okay, Tanya, can you do this example?
Okay.
Can you do this example so that for progress sake?
So now we've
Tanya?
got yeah. Yes.
Are you winning?
Yeah, I think I am.
Okay. Sorry, Tanya.
Yeah.
Okay.
Hello. Shannon.
I think you are supposed to you're supposed to say I'm available. You're supposed to system out to print in. Then you open your code. Can you get the person one?
I think we are not getting the issue of access modifiers here. If you look at that, in your class person, you've actually create the field or the name, that variable string name. If you look at it, it's private, and you are trying to access it in another class. It's private, you cannot access it. So you need to use the get name there. You need a public method to access that. That's about encapsulation. You make the fields or the attributes, you make them private, and then you create the set names and the getter names, which are public, and then use such methods to access to access those private attributes. So that's why you are getting an error. You are trying to, so that one is a getter, it's a getter method. So it will return the string if you are trying to get the string value, just like that. Why trying to return a new name? New name is a local variable to the set name. You cannot return that. You can return this dot name.
Okay.
Why are you getting confused? The error is just because you didn't return something there. Yeah, just like that.
All right.
And the error will go. Since it's a method, you need to put those parentheses for a method. Yes.
Yeah. Now it's working. So Shannon, can you just continue now? I think we've tried to demonstrate setters and getters. Yes. So this is the setter.
So can you explain? Yeah, can you explain your code, and also can you explain how are you achieving encapsulation there?
Okay.
Even Shannon
So
can help
since
there.
Can I do Shannon or you want to?
You can do, and I will give you another example so we can do it together.
Okay. Okay.
Or I can explain.
Okay, guys.
Or I can explain.
All right. All right, guys. So we're using these setters and getters to achieve encapsulation. The reason why we use these ones is because since we have made these attributes private, we can't access them in the main class. So what we have to do is we have to make public methods, which are these ones that we've just created, set name and get name, that we can then access these private members using these public methods. So in this class person, we have two attributes here. We've got string name and int age, and they are private. And as it has been said earlier, that the private modifiers will actually make it make these parameters private, and they will only be able to be accessed in this class only. We can't access them in the main method or in any other class of our program. So now, since they are private, we've made these methods so that we can actually access them in the main class or in any other class that we can actually use them. So this is how we actually make use of them in the main class or in any other class that we may want to use them. So we just do set name and then we put the parameter that we have actually that we've stipulated before. You see, the set name has got a string new name, which is the parameter that we have to pass in when we get to the main method. So that string is the name that we have given here, Estanya. And then when you want to call to get the name, we don't actually just get it like we usually do when the parameters are actually public. So now, since they are private, we use this get name and then we can access them. That's why we're able to print this name. So I think Shannon can actually give us another example in the next one as we go.
I think it's enough. I think it's enough. I don't know if there are some people who are not still getting it on encapsulation. I think it's enough on
Say-
encapsulation. You have done enough.
say-
Yellow.
Pane pada kungobvunzawo ka.
Yes, you can ask.
Inonzi chii pama access modifiers edu atinongoshandisa izi panongoshandiswa private only here. What about the others?
I think on what? On the issue of
Encapsulation.
encapsulation. Yes, on access modifiers, yeah, it's only private. And then there are some other non-access modifiers that you can use for encapsulation, especially the abstraction one. The abstraction, you can go and read on that one, which is on abstract methods, abstract classes. On abstract classes, you can go and read on that. Not abstract, it's interface. It's an interface. I'm sure it's an interface on encapsulation. You can go and read about that. But here you use the private. You only make the variables private, and then you use the public accessors, the setters and the getters methods. That's how you achieve encapsulation in Java.
Thanks. Sir.
Okay. What about the others? Do you have questions on encapsulation? Do you have questions on encapsulation? So what I want you to be able to do is actually to understand or to define what is encapsulation, maybe why you need encapsulation, and then be able to demonstrate with an example how you can achieve encapsulation in object-oriented programming using Java. I think it will be enough for you and as well as for the exams. So you can proceed with the presentation. If there are no more questions, you can proceed.
Okay, Tanya, you can share our PowerPoint
Okay.
so that we can wrap up for encapsulation. Can you move to the next slide? Can you move to the next one?
Yeah.
Okay. We also want to talk about advantages of encapsulation in Java and also in object as a tool in object-oriented programming. It improves the security of an object's internal state by hiding it from the outside world. And also it increases modularity and maintainability by making it easier to change the implementation without affecting other parts of the code. It's only that my screen, I wasn't able to share my screen because of network. I wanted to show you how to update information without even affecting the whole source code. And also it enables data abstraction, allowing objects to be treated as a single unit. As I said earlier on about capsule, and also it allows for easy addition of new methods and fields without affecting the existing code. And last but not least on advantages, it supports the object-oriented principle of information hiding, making it easier to change the implementation without affecting the rest of the code. I think that is all about advantages of encapsulation, and it comes also with the disadvantages. That is, it can lead to increased complexity, especially if not used properly. If you don't encapsulate properly, it can also lead to complexity. Like for an example, you can use other access modifiers like protected. It can also lead to complexity of the code because some parts you can access your code, and also can make it more difficult to understand how the system works, and also may limit the flexibility of the implementation if not handled properly. Can you continue with our slide, Tanya?
Okay. Okay, thank you guys. I'm going to do inheritance now in Java. So inheritance in Java, inheritance means creating new classes based on the existing ones. A class that inherits from another class can reuse the methods and fields of that class. You can add fields and methods to your current class as well. So this is like the definition of inheritance. It is the it actually it is the mechanism of of creating classes based on the um, based on the existing ones, so to speak. So Java inheritance is an important pillar of OOP, which is object-oriented programming. It is the mechanism in Java by which one class can inherit the features of another class. Important terminologies used in Java inheritance. There's class, which is a set of objects which shares common characteristics, behaviors, common properties, or attributes. It is not a real-world entity. It is just a template or a blueprint or a prototype from which objects are created. Which is it's more like a template that actually that we build our objects from. So there's a superclass, which is the parent class or the base class. This is the existing class from which you want to inherit properties and methods from. It serves as the blueprint for creating subclasses. It can have fields and methods, some of which can be marked as protected or public to allow access to subclasses. So I'll just explain more about this when I get to do the code. So there are also this is the subclass or derived class or child class. This is the class that inherits the information or the functionality of the superclass. So it uses the extends keyword to achieve the inheritance, and subclass can also have its own additional fields and methods in addition to those inherited from the superclass. It can also override methods inherited from superclass, allowing for polymorphism. We also get to polymorphism just after inheritance. So here's the example of inheritance. I'm just going to explain this one and then I'll go into the code and do something else about the inheritance. So we've got a superclass animal with a method makes sound. We're just gonna print animal makes a sound. Then there's a subclass, which is gonna extend the class animal. So this subclass is called dog, which is gonna extend the class animal, and the dog class inherits the make sound method from animal. So void make sound system.println.dog bags. So it's the same that is in class animal, but the only thing that has changed is the code that is inside the class. So the name of the class is the same and the number of parameters is the same. It takes no parameters. And then there's a void fetch that is also in the dog class. So as you can see, the subclass can also have its own method. For example, now this dog class does not only have the void make sound from the class animal, but it also have another class of it. It also have another method of its own, which is void fetch. So I'm going to explain the extends keyword as well. In Java, the extends keyword is used to establish an inheritance relationship between classes. It is used when defining a subclass that inherits properties and behaviors from a superclass. So this is more like a predefined keyword in Java that enables us to actually reuse our to inherit the properties of another class. So here's how the extends keyword works. Defining a subclass To create a subclass, you use the extends keyword followed by the name of the superclass. This declaration indicates that the subclass inherits the fields and methods of the superclass. The subclass can add its own fields and method in addition to those inherited from the superclass. I've already said this as well. So here's an example. Class superclass, and then the subclass extends superclass. It's just the same as the code that we've seen above. So inheriting fields and methods. When a subclass extends a superclass, it inherits all public and protected fields and methods of the superclass. So it inherits all the either the protected or the public fields. They're all inherited by the subclass when during inheritance, and private members of the superclass are not accessible in the subclass. The subclass can use the inherited members as if they were defined within the subclass itself. So before we go to method or overriding, I'm just going to demonstrate these examples of inheritance in my Eclipse IDE. Just delete it. Maybe I can leave this class person. Okay, so age for now we're going to create a constructor. See. Okay, so now okay, so we're going to create another class. Let's call it maybe employee. So this is supposed to extend class person. So public class employee extends person. Now let's give this employee something else, maybe an ID. make it integer. Then I'm going to for this to work, we have to put something else here. We need to provide a constructor.
Why do you have any error on class employee?
It's because I haven't put in a constructor in yet. Just because in the person .java, there's a constructor that is taking two parameters,
Okay,
string
it's
name and
okay.
int age. So
It's
now
okay.
I have to put another constructor in this one so that it can clear the error. So public right? So I go to the main method here. Let's clean this up. Now let's create an object here. Here. Argument, the name, there is no encapsulation in this one, so we should be able to print these values easily. If you run this program, if it doesn't have any errors, it should print Tanya. But now it's saying now, which means we do have a problem somewhere. Sir, can you help us here?
You have created your code there. Which variables are you trying to use on edge? Is it from the edge? Is it from the employee class?
No, it's from the
Which
person class, from the super class.
from the person class?
Yeah.
Can you go to the employee class?
Okay, here we are.
Okay, just wanted to see what you have in your class. You're extending the person class and you are passing the name and the age through the constructor, through super constructor. Then go to the person class again. Go to the person class.
Yeah.
And then you are passing the name as well as the age. I think it was supposed to work, but just try to use what can you use there? Just try to use the object. Just create an object and then initialize the name directly without using the constructor.
All right. So should I just
Yes.
get rid of the constructor or?
Yeah, get rid of the constructor, get rid of it. I'm sure maybe you are misusing the super keyword.
Yeah, maybe.
It's the super keyword that you are not using correctly. Just remove it and then I think you need to remove one bracket there.
Yeah.
Yes. And then just call I think you can do it in the
main.
main class. In the main class,
Yeah.
yeah. You can just create a new object and then just below that you can set the age as well as the I think you can set the name as well as the age through the object there. I think that's the easiest and the straightforward way.
Thank you so much.
And it's enough to demonstrate that the name and the age, they are coming from the person class and they are not in the employee class, but through inheritance we are inheriting them from the I'm sure it's now working. We are inheriting
Yes.
them from the person class.
Yes.
So you can just explain more.
All right. Just want to do one more thing here. I just want to set this ID as well. All right. So guys, let me just explain this code. Um, so we've got this person class here, which is our super class, and we've got this employee class, which is our subclass that is inheriting this person class. So this employee class by default, when it extends this person class, it then inherits everything that is in the person class. So now we didn't write anything to do with the name and age here in the employee class. But if we create an object of an employee class, we can still access and use the variables that we have created in person, which is name and age. So, and as well, we have got this new variable here, which is public int ID, that is not in the superclass person, but it's only available in the employee class. So if we go to the main here, we can access everything that is explicitly in the subclass, as well as everything that is in the superclass person. That's why we were able to actually set the name, age, and ID to the employee, and this employee is actually an instantiation of what of the employee class. So that's our code here, and it's actually working well. So I don't know if there is anyone who have got a question on this code before I get back to the presentation and proceed. I guess I can just proceed. So let me. Okay, why do we need Java inheritance? There is a code reusability. The code written in the superclass is common to all subclasses. Child classes can directly use the parent class code. So that's what we have been doing now. So we're actually using the code that was in the person class in the employee class. So that's an advantage, and that's one of the reasons why people need Java inheritance. There's a method overriding. I'm going to demonstrate this. We can also do method overriding in inheritance. I think that's the only way we can achieve overriding is through inheritance. So it is one of the ways by which Java achieves runtime polymorphism. We'll get to that. Abstraction, it's the concept of abstraction where we do not have to provide all the details is achieved through inheritance. Abstraction only shows the functionality to the user. So abstraction, I think there was a presentation that was done on abstraction. It's a way of actually hiding all the unnecessary data from the user and only providing the interface or the layout that the user is more comfortable with or what the user needs to access, and everything else will be abstracted away. So we have got these types of inheritance. I think there are about 7 types here, but I'm just going to explain only about 4 of them. So there is single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, hybrid inheritance, cyclic inheritance, and simulated inheritance. So I'm going to explain single inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. Single inheritance in Java refers to a scenario where a class inherits properties and behaviors from only one superclass. In other words, subclass can only have one direct parent class. This is what we have just demonstrated. That inheritance that I was demonstrating is actually single inheritance, whereby we only have one class that is acting as a superclass and one that is acting as a subclass. That was it. So we also have multi-level inheritance, which is a type of inheritance in which class inherits from a subclass and another class inherits from this subclass. This creates a chain of inheritance with each class building upon the one before it. So it's like you've got classes A, B, and C, and then class B inherits from class A, and then class C inherits from class B. So it's just like a chain. So it's multi-level because there is more than 2 levels of inheritance. It's like in this example here, we then make another class, let's say, which maybe management, that is also that is being extended from employee. So we have got person, then employee, then management. So it's more like a chain of inheritance. So that's what we call multi-level inheritance. So as we proceed, I'm going to explain as well the
So can we safely say we do not have multiple inheritance in Java? Or can we safely say multiple inheritance in Java is not actually allowed?
Yeah, it's not because it's
Can you explain why?
I had it causes what they call a diamond problem or something like that. Which
Yeah, imagine we've got a class which is actually inheriting maybe from two classes, and those classes maybe they've got a common method. Which one are you going to call? Something like that.
sure.
So the multiple inheritance in Java is not allowed. Maybe you can do a cheat code through interfaces, but it's no longer inheritance there. When you both a class can implement more than one interface. So multiple inheritance is not allowed in Java.
Yeah. Okay. Thank you so much. Thank you for clarifying on that one.
Okay.
So we also have hierarchical inheritance. This occurs when multiple classes inherit from a single superclass. In this scenario, a single superclass serves as the base for multiple subclasses, each of which may have its unique attributes and behaviors. I think this is one of the most common types of inheritance, whereby you can have, like, let's say we have got a company that make cars. So we can actually make so many models out of that car. So for each model, we can have a separate class. All those classes will be inheriting from the superclass cars. So it's more like we have got two or more classes that are actually inheriting, that are extending just one superclass. So that's hierarchical inheritance. And then we have got hybrid inheritance, which is a combination of more than one of these.
I think on inheritance, I'm sure it's enough. They can go on to read on those because it's just the types. I think there isn't much complex. Maybe you can look on the advantages so that you can go on to polymorphism. You're supposed to present also on polymorphism, right?
Yeah, I'm going to do that because the person who was supposed to present it is having network problems as well.
Yes,
So
yes. So let's move. Let's
Okay,
move.
so
I give you 30 minutes maximum to finish everything.
all right, so thank you so much. On advantages of coding of inheritance, there is code reusability that I think we have actually explained this one before. There is hierarchy organization whereby inheritance allows the creation of a hierarchical relationship between classes, enabling the group and categorization of related objects. This helps in organizing and structuring code, making it easier to understand and maintain. There's extensibility and modifiability. Inheritance provides a way to extend and modify the behavior of existing classes without modifying their source code directly. Subclasses can add new methods or override existing ones, allowing for flexible and customizable implementations. There's also polymorphism. Inheritance enables polymorphism, allowing objects of different classes to be treated as objects of a common superclass. This promotes flexibility and simplifies code design by allowing the interchangeability of objects during runtime. Disadvantages of inheritance, there's tight coupling. Inheritance can lead to tight coupling between classes, especially in deep inheritance hierarchies. Changes made in the superclass may have unintended effects on subclasses, making the code more fragile and less maintainable. There's inheritance hierarchy complexity as well. As the inheritance hierarchy grows, it becomes more complex and difficult to understand. Um, Code duplication and overuse. Um, Inheritance may lead to code duplication if classes inherit unnecessary or irrelevant properties or behaviors. Overuse of inheritance can make the code base bloated and harder to comprehend, and it can also make the program a little bit slower through these irrelevant properties or behaviors being taken from the superclasses. Limited flexibility. Inheritance establishes a static relationship between classes and at compile time, limiting flexibility to change the relationships dynamically during runtime. This may restrict the adaptability of the code to changing requirements. I think I'm going to end here on inheritance. Any questions on inheritance that I can clarify before we further? Okay, now I'm going to polymorphism. Polymorphism is actually, it means having one thing in many forms. Right, I'm going to get into details soon. It describes the ability of the objects in belonging to a different types with specific behavior of each type. So by using this, one object can be treated like another, and in this way it can create and define multiple level of interface. As the name suggests, the name multiple form polymorphism is the way that provides the different functionality by the functions having the same name based on signatures of the methods. There are two types of polymorphism. First is runtime polymorphism, and the second is compile time polymorphism. So I think the runtime polymorphism is the one that uses method overriding, and it needs inheritance. So that to be implemented, it needs inheritance because we can't override without inheritance. And as well, overloading is the compile time polymorphism. So when one task is performed by different ways, that is known as polymorphism. Okay. All right. So we're gonna get into this example. For example, think of a superclass called animal that is a method called animal sound. Subclasses of animals could be pigs, cats, dogs, birds. They also have their own implementation of an animal sound. The pig oinks and the cat mews, etc. Class animal. So here's the example. Class animal, a public void animal sound. And then there's this code inside this function. Inside this method, just gonna print the animal makes a sound. There is another class pig, which is extending animal. It's got the same method as the one that is in the animal class, which is public void animal sound, and it is also the same parameters, but the code that is going to execute is a little bit different. So this one is going to print the pig says we. So there is also class dog that is also extending the animal, and it's going to print a different line as well, but the methods in these classes are the same. So that's what we call polymorphism. You can have the same method, but they are being implemented in many different forms. So the name of the function of the method is the same, and the parameters is the same, but the only thing that is different at the moment is the code that they're actually being asked to do. Okay, I'm going to jump onto the types of polymorphism. I've already said that we've got compile time and runtime polymorphism. So compile time is also known as static binding, whereas runtime polymorphism is also known as dynamic binding. Method overloading is an example of static polymorphism, while method overriding is an example of dynamic polymorphism. as I have said, method overriding happens under the implementation of inheritance, and method overloading, it doesn't need inheritance to be implemented, just because we can actually overload methods in the same class. So an important example of polymorphism is how a parent class refers to a child as object. For instance, let us consider a class animal and let cat be a subclass of animal. So any cat is an animal, So now we are actually going into the is a relationship. So in this case, cat satisfies the is a relationship for its own type as well as its class animal. Static polymorphism in Java, static polymorphism is achieved through method overloading. Method overloading means there are several methods present in a class having the same name but different types, order, or number of parameters. So overloading, it means you can have the same name but you can have different types or order or number of parameters. For example, can you have a method like greet that takes the person's name as a parameter, as an argument, and then we can have another one that doesn't take anything. Those two methods can dwell peacefully without causing any problem, any errors, because they are considered different by the Java by the languages. So I mean, they will be considered two different methods because they've got different arguments or parameters. So if we have to perform only one operation having the same name of the methods, increases the readability of the program. Suppose you have to perform an addition of the given numbers, but they can be any number of arguments. If you write the method such as int for two parameters and b int, so there's a int for two parameters and b int for three parameters, then it may be difficult for you to understand the behavior of the method because its name differs. So we can perform overloading to figure out the program quickly. So the way we can figure out this out is we can actually have these methods. We can give these methods the same name like a or add int, and then we can give another one add and then int. So when you're in our code, if we pass three arguments, the program will actually call this function that has got three arguments. If you put in two arguments, then the program will call the one that has got two parameters. So different ways to overload the method. We can overload by changing the number of arguments or by changing the data type of the arguments. So now we're going to dynamic polymorphism. Runtime polymorphism or dynamic method dispatch is it's a process in which a call to an overridden method is resolved at runtime rather than at compile time. In this process, an overridden method is called through the reference variable of a superclass. The determination of the method to be called is based on the object being referred to by the reference variable. So we can achieve polymorphism through overriding as well, other than just overloading. So if a class inherits a method from its superclass, then there is a chance to override the method provided that it is not marked final. So there's this issue of the final keyword. If something is marked final, then it means you cannot override that method. But if it's not marked final, it means it can be overridden. The benefit of overriding is the ability to define a behavior that's specific to that subclass type, which means a subclass can implement a parent class method based on its requirements. So we can have like that example where we've got we've got animals, and a cat can meow and a dog can bark. They are all making sounds, but they are now doing it specifically because the cat is doing it its own way and the dog is doing it its own way. But both are calling the same method, but they're actually modifying it to use it based on the requirements. So in object-oriented terms, overriding means to override the functionality of an existing methods. Okay, there's rules for overriding. The argument list should be exactly the same as that of the overriding method. So this is where it actually differs more, much with the from overloading, because we have already said that on overloading we don't even have to have different parameters or arguments. We can have the different parameters and the same name, but we can make the
can you demonstrate polymorphism and then you come to explain these rules? Maybe you can have a code and then you can come back to explain these rules. It will be better for people to understand, and do it quickly, please.
All right, say.
Yes, because it's now half 7. I need to travel, so please do it quickly.
Okay, say thank you. Now we've got this public class person. We're going to make to create a method here. Right. So now if you go to the main class, so now we've actually we've done the overloading here. We've got the same method grid, but this one is taking no and it has got no parameters, and this one has got the parameters of string type. So if you go to the main method here and actually try to call this one is employee, okay, or maybe I can just now if to get to so if we run this program,
But you can also access the grid, I'm sure, through the employee as well, through inheritance. You
yeah,
can do that as well. Okay, also, I think you have actually used the name variable there and initialized to case. Why not just pass that when you say audio there? I'm just saying,
yeah,
I think
yes,
that
it
was
makes
the
sense.
idea there.
Yeah, yeah,
I
it
think
makes
that was
yeah,
the idea there.
yeah, it was. So this line was not necessary, right? No,
You can still use it
no.
instead of saying audio. You can just say person dot name there. You are just passing that case to that greet method. Then you can say hello case, but it's still fine.
All right, say
Yeah, you can just say person dot name there, just like that. I'm sure it will work. Yes,
yeah, it
and
works.
if you run that, I think that was the main idea when you created that. When you initialized that variable with the case.
Yeah, yeah, sure, that was it.
Yeah, so I think you can now explain what's happening there.
Okay, so in this person.java, this is the class that we're working in. So we have two methods here. They look the same. In fact, the names of these methods are just the same. They are both public void greet, public void greet. Only thing that is different now is that this one is taking no arguments, and this one is got it's going to take the name as an argument. So the reason why this is working is because of that is taking this one is taking parameters and this one is not taking anything. So if we actually delete this like this, it's gonna give us an error because now it's actually taking these two methods as one method, and it's actually telling you that you have one method, you have two methods that have got the same name and same parameters. So it's now saying that the duplicate method creates entire person. So what you can do is you can either rename it or you can change. You can just do like what we um, give it a parameter that is going to take from the user or something like that. So this is one way of overriding. The other one is you can actually, since you can even have another just okay. So now these ones now they look the same, but if you add one more like the int age, then it's gonna clear the error, which means this you can override this in 3 different ways, like what I've done here.
Are you overriding or you are overloading?
Sorry, overloading. Sorry, I
Thank
mean
you.
overloading. Thank you so much. So now, so this will still work. So if you go to the main, and we just give this great another parameter here, and argument in just 2%. Change it here, okay. Now if we run our program now, expect this other line to be okay. Now they're all, it's printing it on the same line because I didn't add a new line, but I think you can see what is happening here. Yellow user, yellow case, you are 26 years old. So this is what we mean by polymorphism. We've got this great method which is being three different forms because we've used parameters and different data types, but the name of the method is still the same. So I don't know if anyone has got a question there, and now I'm going to just wrap up in the PPT because I think we are running out of time. So argument list should be exactly the same as that of the overridden method. Now it's pity that we didn't get time to do overriding. But maybe I can just quickly demonstrate because I still have this other class open, this employee class that is extending the person class. So we can normally we use following program has been overridden. Take care of may arrive during runtime. right, so now if we go to the main method here, we have this employee. We're just going to do employee.greet. It's supposed to print this line. This is an overriding method. Run it. There we go. It's printing. This is an overridden method. So I think I've tried to just demonstrate what overriding means. So we actually can actually attain it through inheritance, and this is an inherited. This class is inheriting the person class, and we are overriding the method that is in the person class. So we're now overriding it in the child class, which is employee class. Okay. I don't know if people have got questions there, but I'm just gonna go on with the PPT.
Can you call
So
the greet method there on employee?
yeah.
Okay, it's okay. Maybe yeah, I see it.
I did
I
say
was just off. I was
okay,
off. Okay, it's okay. I was off the mic.
all right. So can I proceed with the presentation, the PowerPoint?
Now I'm sure now you can explain what you were trying to explain on the slide there. You can now
Okay.
explain and show us.
Okay, thank you. So the argument list should be exactly the same as that of the overridden method. So now we've done the overriding. So the argument list, as you can see, let me just. Now I've overridden the greet method that doesn't have any parameters. So as you can see now, I've also called the same method and I've overridden it, and I didn't put any parameters inside. So it has to be the same. If I have to override the one that has got if this method had parameters in it, I was supposed to just provide those same parameters on this when overriding.
So in other words, if you want to override the number of arguments, if the arguments must be the same.
Yeah.
And if in their order, they must be the same.
Yes.
Even the return type must be the same.
Yeah.
And even the modifier must be the same for you to override a method. That's what we are saying. So if it is public void, then the name there, everything must be the same. To the argument list must be the same so that you can actually achieve overriding. That's what you were actually trying to explain there.
Yeah, that's it. Thank you so much. I don't think I can do anything more here. I think Save just explained. So now this is more like a distinction between method overloading and method overriding. So method overloading increases the readability of the program. Method overriding provides the specific implementation of the method that is already provided by its superclass. Method overloading occurs within the class, whereas method overriding occurs in two classes that have is a relationship. In this case, the parameters must be different while doing method overloading, but in method overriding, the parameters must be the same. So I think we've already done the advantages of polymorphism. Or maybe let me just go through it in case if we didn't. There's code reusability, but we have explained these things. Then there's flexibility and extensibility. There is readability and maintainability. There's code modular. And the disadvantages of polymorphism, there is runtime overhead. Polymorphism involves dynamic binding, which occurs a slight runtime which incurs a slight runtime overhead compared to static binding. The determination of the specific method to be executed is resolved during runtime, which can affect performance, especially in performance-critical systems. So at some point, this can actually slow down the program or the system. And there's also complexity. Polymorphism can introduce complexity, especially when dealing with large code bases or complex inheritance hierarchies. Potential abstraction leakage. Improper use of polymorphism can lead to abstraction leakage, where specific implementation tails of subclasses are exposed through the common interface. The learning curve is a little bit steep and difficult, and I think a lot of programmers find it difficult to implement polymorphism. So in summary, encapsulation is the process of combining data and functions into a single unit called a class. It allows data to be hidden and protected from outside access. Only methods defined within the class can manipulate the data, ensuring that data integrity and security. Encapsulation helps in achieving modular and reusable code, as well as maintaining code readability and understandability. Inheritance is a mechanism that allows a class to inherit properties and behaviors from another class called superclass or base class. The class that inherits the properties is called the subclass or derived class. Inheritance promotes code reuse and helps in creating a hierarchical relationship between classes. The subclass can extend and specialize the behavior of the superclass, adding new methods or modifying existing ones. This allows for code organization, abstraction, and modularity. Polymorphism refers to the ability of objects to take on many forms or behave multiple behaviors. It allows objects of different classes to be treated as objects of a common superclass. Polymorphism enables the use of a single interface to represent different types of objects, providing flexibility and extensibility in code design. It is often achieved through method overriding, where subclass provides its own implementation of a method defined in the superclass. Polymorphism enhances code reusability, maintainability, and flexibility. Access modifiers are keywords in object-oriented programming language is that control the visibility and accessibility of variables, methods, and classes within a program. So, ladies and gentlemen, I think this is the end of our presentation for Group 4. I don't know if you've got any questions you can ask, but I think we've gotten what we wanted to and say. It's leaving it to you. Sir.
There is a hand by Dakarai. There is a hand by Dakarai. Is it a contribution? Is it a question? Please proceed. You may go ahead.
It's actually a question, sir.
Okay.
Yeah, I guess I heard the presenter saying static binding is an example of method overloading, if I'm not mistaken.
I'm sure the presenter is still around.
Okay. It's not
Is that
an
it?
example. Maybe I actually made a mistake there. It's not an example of method overloading, but it's actually more like a type of polymorphism, and it can be implemented through method overloading.
Okay. So my question is actually on static binding, the actual meaning of static binding. Can you please explain a little bit more about static binding?
I saw your teacher.
Okay, static binding is it's just like how can I it's the same as runtime polymorphism. So if you can understand runtime polymorphism, you can understand it just because it's just a different name or a different terminology that is used to refer to runtime polymorphism.
Okay.
Yep. So I think from my understanding, I think it's more like, it's static. It's not dynamic. It's static, which means It's like there's I think it's oh gosh no that's
Yeah, just need the actual meaning of binding, like binding in general in Java, binding, not
binding is
stick.
just like joining of bits and pieces, you know, of let's say if you let's say we are inheriting something from another class or something like that. So it's taking all those pieces together to combine something that is that it wants to achieve.
Okay,
Right.
okay.
So I think in a short, when I talk of a static binding, is something which actually happens during the compile time. So by the time you compile the program, actually everything, actually the object of the program knows if it is a method which is going to be called, this is the method that I'm going to call. If there is a need of actually doing some calculations or doing some operations, I'm going to use this at compile time. If it is dynamic, it's now at runtime. We can do the manipulations, or we can actually decide which method I'm going to use at runtime. That's the dynamic part. You are going to change something, or you are going to know that I'm going to use this actually at runtime during the execution of the program. So when we talk of static and dynamic now in a polymorphism, we are saying if it is method overloading, we know which method we are going to execute actually at compile time. Because during the time you compile the program, if you actually code the method with the 2 arguments, we know at compile time that the method that we are going to call is this one if you are using the method of overloading on a polymorphism. Why? Because there's going to be one method with exactly what? 2 arguments. If
Okay.
it is, if you are going to use the dynamic one, which is the runtime polymorphism, you are going to decide the method to execute during the execution of the program. That's what you are going to decide. You are going to look at the object which is going to call the method, which is going to call that method, and then we can decide by scanning through the classes. If you are in person class, if you are using the person object, which method is going to be called? If you are using the employee object, which method is going to be called? Just like that. If it is employee class, which is calling the greet method, we look first maybe in the class, have we actually override the method which was in person? If we have actually overridden that method, we are going to call the one which is in employee. But if we didn't override that method, we are going to call the one which is coming from the person, and then just call that on the object, on the employee object, and then the employee is just going to say whatever which was said by the person class. But if you actually override that at runtime, we can decide. So you see the dynamic part, we are just deciding at the runtime which method we are going to execute. But if it is on overloading, it doesn't matter. We are just going to pick the same method that we actually decided at the compile time.
Okay.
Just
Thank
like
you.
that.
Yeah, I think it's a little bit later.
Okay, it's okay.
Thanks.
Nice.
Okay,
So do
thanks.
we have more questions? Do we have more questions or contributions? I welcome as well. Do you have questions or contributions? Okay, I'm no longer seeing hands. Maybe people now want to rest. The group 4, where is your group leader? I didn't see your group leader in here. Where is your group leader? There is a hand again, or was it a hand? Okay, I'm sure.
Sorry, sir.
Yes,
Hello,
Dagara.
sir.
All right, I was just saying, I don't think he did manage to get into the presentation, but I think by the day we are going to present, he will be available.
Group 4 or group 5? I'm asking for group 4. Those who are presenting.
Okay, okay.
Yes. Where is it? I didn't see her. I'm sure she's your group leader.
Yeah, she is, but I think she didn't make it.
Okay, it's fine. So if we do not have more questions, I'm sure there's one concept that was left on object-oriented programming, which is the abstraction. I'm not going to dive into that because we no longer have time for that. I've actually forgot to put it on your presentation. You're supposed to present also on abstraction. But I'm trying to see if those who are presenting on threads, may you please just add the abstraction on your slide. I'm sure it's group 5. Just add that, you present on that one first and then you dive into threads. Yeah, I think it will work that way. So I think we can call it a day. We can call it a day. If we do not have more questions, we can call it a day.
It's okay, say thank you.
Okay. So thank